Breakthrough. Magnetic field on Martian surface 10 times stronger than expected. I'm Steve Belair. Welcome to Breakthroughs. New data gleaned from the magnetic sensor aboard NASA's InSight spacecraft is offering an unprecedented close-up of magnetic fields on Mars. In the study published today in Nature Geosciences, scientists reveal that the magnetic field at the InSight landing site is 10 times stronger than anticipated and fluctuates over timescales of seconds to days. One of the big unknowns from previous satellite missions was what the magnetization looked like over small areas, said lead author Katherine Johnson, a professor at the University of British Columbia and sensor scientist at the Planetary Science Institute. By placing the first magnetic sensor at the surface, we have gained valuable new clues about the interior structure and upper atmosphere of Mars that will help us understand how it and other planets like it formed. Before the InSight mission, the best estimates of Martian magnetic fields came from satellites orbiting high above the planet and were averaged over large distances of more than 150 kilometers. The ground level data gives us a much more sensitive picture of magnetization over smaller areas and where it's coming from, said Johnson. In addition to showing that the magnetic field at the landing site was 10 times stronger than satellites anticipated, the data implied it was coming from nearby sources. Scientists have known that Mars had an ancient global magnetic field billions of years ago that magnetized rocks on the planet before mysteriously switching off. Because most of the rocks of the planet are too young to have been magnetized by this ancient field, the team thinks it must be coming from deeper underground. We think it's coming from much older rocks that are buried anywhere from a couple hundred feet to 10 kilometers below the ground, said Johnson. We wouldn't have been able to deduce this without the magnetic data and the geology and seismic information InSight has provided. The team hopes that by combining these InSight results with satellite magnetic data and future studies of the Martian rocks, we can identify exactly which rocks carry the magnetization and how old they are. The magnetic sensor has also provided new clues about a phenomenon that occurs high in the upper atmosphere and space environment around Mars. Just like Earth, Mars is exposed to solar wind, which is a stream of charged particles from the Sun that carries an interplanetary magnetic field, IMF, with it. It can cause disturbances like solar storms, but because Mars lacks global magnetic field, it is less protected from solar weather. Because all of our previous observations of Mars have been from the top of its atmosphere or even higher altitudes, we didn't know whether disturbances in solar wind propagated to the surface, said Johnson. That's an important thing to understand for future astronaut missions to Mars. The sensor captured fluctuations in the magnetic field between day and night and short, mysterious pulsations around midnight, confirming that events in and above the upper atmosphere can be detected at the surface. The team believed that the day-night fluctuations arise from the combination of how the solar wind and IMF drape around the planet, and solar radiation charging the upper atmosphere and producing electrical currents, which in turn generate magnetic fields. What we are getting is an indirect picture of the atmospheric properties of Mars, how charged it becomes and what currents are in the upper atmosphere, said co-author Anna Middelholtz, pre-doctoral fellow at the University of British Columbia. And the mysterious pulsations that mostly appear at midnight and only last a few minutes, we think these pulses are also related to the solar wind interaction with Mars, but we don't know exactly what causes them, said Johnson. Whenever you get to make measurements for the first time, you find surprises, and this is one of our magnetic surprises. In the future, the InSight team wants to observe the surface magnetic field at the same time as MAVEN orbiter passes over InSight, allowing them to compare data. Right on. I'll leave a link in the description, and as usual, please like, share, subscribe, and take care.